Hello, this is Jack Jackson back again. In this video, we're going to do an application problem starting with the formula of a PDF, probability density function for continuous distribution, and working through using some pretty high-powered stuff on a calculator here. Okay, so we're going to use a Ti-84 and a Ti-nspire to do this. So the time until failure of a product is modeled by the following probability density function, where x is time in years until failure. PDF of x is 1 over 25 times x times e to the negative x over 5 for x is greater than or equal to 0, and then it's, of course, it's 0 for x is less than 0. Sort of obvious that the product, it's not going to fail before you buy it, or if it does, it's not your product anyway. So this is only for positive x's that this makes sense. So first of all, use the calculator to graph the PDF and CDF in an appropriate window. Okay, so let's use the calculator technology here. In Y1, put the formula in. Actually, I can even do this. I can use alpha F1 and number 1 to get a fraction that looks like that. 1/25 x e to the power negative, and again, if I want a horizontal fraction, I'm not sure if it'll do it within, yeah, it will, x over 5. So I can get it to look pretty much just like it does when you write it by hand. Now, I always want this to be set up the same. So y1 is the PDF. CDF will be the integral from L to x of y1 dx. Now I just have to put the right number in L, and in this case L is 0. So it's 0 store alpha L. And so I want to do that. What do I choose for L? I choose a place where this formula starts, and to the left of that the probability is 0. And so 0 is the appropriate thing in this particular case. Now we just need to find, this is going to graph really slowly, so I'd like to have a good window. This is probably a pretty good window from 0 to 50. If it does get stuck, remember you can hit on and it'll just stop it. It'll graph the PDF pretty quickly, but the CDF very slowly. This is a good window for my y's on all CDFs. Certainly we want to start x at 0. 50 years is probably enough. We might not need to go out that far. I think actually probably let's try something less. Let's try 25 years, and let's see what happens with that. I've got it marked off every 5. So here it is, starting at 0, comes up and then back down and levels back out. There's the PDF, and the CDF should start at 0 here and climb up to eventually level out at 1. Now it may take a slow trek to get there, but it will get there. While that's doing its thinking, and you may have to wait, not too long, but a little bit for this one, let's do the same thing on an nspire. Now, the easiest thing to do here on nspire is I've actually got the CDF set up, and CDF of x, well, I've got something already stored in there. But CDF of x, I think is, let's see if this works. We need to find the right PDF of x. So it's 1/25. This is going to change here in just a second. X times e to the power, the opposite of x over 5. And I want to get to the end of that and then store that as PDF of x. Now I think the way I've got this set up, this will automatically change CDF of x as well. Okay, so let's see if it did. CDF of x now should be an appropriate. It may actually give me a formula for this. Yeah. That's actually the formula for the CDF, using some fancy calculus stuff that's built into the calculator, since this is a CAS version. Okay, but what it is, CDF, what I put in there was what I put in there in an earlier video, the integral from low. Oh, I've got to put the right value of low to make this work, by the way. But so that means I have to store 0, store as low. It is already. That's why it worked. So it is correct. But I need to do that first. And then now if I do CDF of x, it will be the right formula. I think it already had 0 in there, so it should be. So I don't think it's going to see it change. Now, if I want the graphs, well, actually there they are, because in my graphs I have, look at the formulas, I just have PDF of x for y1, f1, and then CDF of x for f2. And so in blue you see the PDF, and the red you see the CDF, and of course the graphs are bigger, a little better resolution mainly, and in color on this one here, so you can see a little bit better what the shape of the graph is. It's not as pixelated as the low resolution screen is over here. Okay, so now we have the graph both on the I went out to 50 here, which maybe is a little better than what I had over here for 25, because I can actually see this leveling out at 0 down here for the PDF and at 1 for the CDF a little bit better. They both start at the origin. Okay, so anyway, there's the graph of the CDF and the PDF. Okay, now, okay, that was the first thing that we wanted to do. So there's that. Screenshots. By the way, if you have the older operating system, this is what it looks like. Newer one looks like this. Either way, you've got to store 0Z, choose a window, get a graph. There's essentially the same thing. Store this as a PDF, and then put those in, graphed it. There we have it. Use your calculator to verify this is a legitimate PDF. We know that just by looking at it on the graphing window that from 0 on the y values are above the axis. We can kind of tell it by just looking at the CDF. We can see it goes from 0 to 1. So really that's enough, or we can find the area under this thing. So if we want to go a little bit more, we could go to the home screen here and then say we could just do the CDF of some large number, or we could say we could integrate the PDF from 0 to infinity, the PDF of x dx. So this is the cast version of the calculator, so I can put in infinity, and this will tell me, yeah, that is 1. Now, the same sort of thing on the Ti-84, we can quit this, go to the home screen. We can do Math 9. I can go from 0. I can't put in infinity. I can put in something big. Let's see, what did I try before? I think I used 100, 200. Looks like I used 200. Okay, so 200 instead of infinity seemed to be okay. And my formula is in Y1, so I can just go here to get Y1 for my PDF and do this. And this should come out to be at least approximately 1. Okay, good. So there, it's a legitimate PDF, and we have it. There's the same thing on the calculators. What's the probability that an item will fail within the first 5 years? What's the probability it will last more than 5 years? Well, I'll tell you this right away. More than 5 years is just 1 minus the probability less than 5 years. So once we find the first part, we just subtract from 1 for the next part. So I can do it this way. Here, I can go back and take that same thing I did here, but within the first 5 years is from 0 to 5. Okay, and it's that, and 1 minus my answer will be, whoops, 1 minus, yeah, it's still the same answer. So 1 minus that answer will be that. So there's the probability of, so about 73.6%, about 74% that'll last more than 5 years, about 26% less than 5 years. We can also shade it. See it as, we can see it two ways on the graphs here. So I can do calc and number 7 and make sure I'm on the PDF graph, and I can go from 0 to 5, and it will shade that and do a probability, which also, if you go right above this, it will be the Y value. So if I just do a trace and make sure I'm on the CDF curve and put in 5, I'll get the same Y value there. So you can see how those connect to each other. Of course, since I have this in as Y2, I could have also done it this way. I could have said, well, that's just Y2 of 5 for the first one, for the 0.26 something, and then 1 minus that for the other one. Okay? And I can do a similar thing on the Inspire. Okay, what about the probability will be somewhere between 3 and 6 years? Well, since I have it in as Y2 already, I could use the CDF and say, well, that's Y2 of, what did I say, between 3 and 6 years. So it's Y2 of 6 minus CDF, which is Y2 of 3, between 6 and 3 years. That'll work out. I can also do it by math 9 and just say go between 3 and 6 years. And then this is the PDF, so this is Y1 dx. That will also give me the same answer. Do a similar thing on the Inspire if I want to. I could also shade it, right? All right, for the mean life expectancy, I need the CDF, which is in Y1, and all I do is I go, I don't need that. Let's get that. I want this. And so I can do, let me pull that back again. I want to go here, and this needs to be insert x times that. This is for the mean. And I need to do for all x's. We say practically all x's was if we use 200 for the top, and we definitely want to use 0 for the bottom. Really should be 0 to infinity. That's approximately 10. And if I do it on the Inspire 0 to infinity, it really is exactly 10, and it does an exact value for me. So for this to work, you of course have to know the PDF formula and have it in Y1 for this calculation to work. There's the old operating system, new operating systems 84. The old operating system, I actually typed in the formula, but you don't have to. If you got it in Y1, you can put Y1 there. Here, instead of Y1, I can put the actual formula in place. It's probably easier if you just go ahead and have it in Y1. What about the standard deviation? Okay, well, the standard deviation, what you do is you just pull that entry up like this. Now, I know this is 10, so if this had a lot of decimals, I would just store, well, I'll just go do it this way. I'm going to store it as alpha m. Okay, now let's see if I get back to here. Second entry a couple times. Okay, get back to this. And where the x is, let's see, we want to insert a parentheses. And then back to insert again. X minus the mean, alpha m, close parentheses, square. Use the same 0 to 200. This should work. This should give us at least approximately what the variance is. In this case, it's 50. And of course, then the square root of my answer is the standard deviation. Square root of 50, or approximately 7 point whatever. Here's what the screen looks like on the Inspire. Integrate from 0 to infinity, x minus the mean, square times the PDF. That's the variance. Square root of that is exactly 5 square root of 2, or approximately 7.07, etc. That is the standard deviation. Alright, now, so far, except for just seeing the graph, we really didn't need the CDF. But if we want to do an inverse calculation, an inverse probability, such as the median, this is where we need to know the CDF. So we need to use the technique that we had before, that technique where we put this in right here as Y2 with the right L value and this up here. I'm going to actually turn off this graph. Can't delete it, just turn it off. And the median, I know the probability is 0.5, which is going to graph a horizontal line. And I want to calculate number 5, the intersection. Now I've got to wait for it to graph again, so this may be a little slow. While it's doing its thing over there, let's do the Inspire version. Now I have the right formula in the PDF and the CDF now. So all I need to do on here is tell it to solve. Okay, I want to solve. I can go to here. My formula is in CDF of x. The right formula is in there. And I want to solve where that's equal to 0.5, comma, solve for x. And at least approximately, this should give me an answer. Now, by the way, it gave me 2 answers. Okay, but only one of these actually applies. This one's not in our domain. So the one that applies is this 8.39. So that should be the same thing I get out of calculating an intersection here. I can do the same thing over here that I'm going to do with the Inspire by going to I'm going to do with the 84 by putting in the 0.5, if I'd rather do it this way, which gives you a horizontal line. And now I can go to Menu, Analyze Graph, find the intersection, and I want to choose this graph and this graph. And then you just give it a lower bound and an upper bound, and it finds the intersection point between it. And that's what we got, 8.3917. That's what we have here, 8.3917. I'm going to get that over here. Now it's finally finished graphing on the 84. And so I'm on the first curve. Make sure you're actually on the CDF curve. Use up or down arrows to go between, but be sure you're on the CDF curve first. Then hit enter. It takes you to the horizontal line. Hit enter. If I had the PDF graph with this, I might have to be a little bit more careful. Make sure I got the right 2. Get this as close as you can get. Helps to be pretty close here. It speeds it up a little bit. And then hit for the guess and hit enter. And it's doing lots and lots and lots of calculations to do this approximately, so it's a little slow. But there we come, 8.391735. If I quit and just hit X now, that is the X value that we have there, same as we had here. And so that's the median. Okay, so to do this and other similar probabilities on a Ti-84, remember you have to have the CDF graph, which we have to get from the PDF this way, at least approximately, and graph the cumulative probability to the left, do a calc intersect, and we got it. On the Inspire, you can actually just say solve CDF of x equals 0.5 for x. And just be sure, if it gives you an answer that doesn't make sense in your domain, throw it out and use the other one. Okay, what's the amount of time until 75% of the products are released today will fail? Well, same thing. Instead of 0.5, you put 0.75. Calculate that intersection, and you get that to work out there. Okay, or just say solve and then put 0.75 here, and it works out. Okay, we'll do another example in the next video.